Hello everyone and welcome to ILAN Technology's DINTEK training session. My name's Darren Stribning, Queensland State Manager at ILAN Technology. Today I'll introduce DINTEK LAN Cabling System products and solutions, starting with some background information about DINTEK, followed by an introduction to their products, and wrapping up with some general info about UTP cable and structured cabling. The presentation will be around 20 minutes and there'll be a 5-minute Q&A at the end. Listen-only mode for the presentation will be enabled, and you can raise your hand in Q&A time. You can type your questions or comments in the left bottom. Sometimes there might be a breakage in sound due to network congestion, but please be patient and stay on. If you drop out, you might have to re-register to get back in. We'll save a recorded video on our blog sometime in the near future, but if you want a particular slide, you can click the Save button on the page. We'll start with a little bit about DINTEK and some of their history and standing in the cabling industry. DINTEK Electronic is a leading manufacturer of LAN cabling systems and tools and has won many awards for its products. Founded in 1990, DINTEK is headquartered in Taiwan and has a subsidiary in Switzerland covering the European market. DINTEK manufactures a wide range of network cabling products as well as optical fibre cables and accessories. DINTEK is an ISO 9001-2008 certified manufacturing company, designing and manufacturing all products under the management of a core team in Taiwan to ensure the highest possible product quality. DINTEK's products meet and exceed industry standards. They have certifications from several well-known certification bodies such as SGS, 3P, UL and Intertek. DINTEK employ rigorous quality control systems and close standards associations to ensure the best possible product quality and performance. Ongoing research and development ensures constant advancement in both quality and innovation. DINTEK has headquarters in both Taiwan and Switzerland and have a worldwide distribution network for their products. The two stars on the map here pinpoint the headquarters in Taiwan and Switzerland, while all the dots represent the distributors. There's ILAN down in Sydney on the bottom right. DINTEK is proud to provide a 25-year warranty for a complete installation to be free from defects for projects installed by DINTEK certified installers, provided all components are from DINTEK and all tests carried out per specifications. To achieve this goal, DINTEK offers a DCI, a DINTEK certified installer training course. The DCI course assures the customer that the installer is qualified to install and fit off all the DINTEK products as specified in the ANSI TIA 568 standards for telecommunications cabling. Here's a short video of the DCI course. DINTEK also ran a DTI, a DINTEK Trained Installer course in Sydney for the first time in November 2017. The DTI is basically a shorter and less in-depth version of the DCI, the DINTEK Certified Installer course. There'll be more in the near future, so if anyone's interested, please send us an email at sales@dintek.com.au to reserve a spot. And now on to some DINTEK products. DINTEK offers structured LAN cabling systems for Cat5e, Cat6, Cat6a, Cat7 and Optic Fibre. For each of these categories, DINTEK supplies all the cables and associated components like patch panels, patch cords, jacks, plugs and wall plates, as well as tools and kits. Amongst DINTEK's extensive cable range is PowerMax 500 Cat6 UTP cable. This cable comes in a 305 metre box and is constructed using 23 AWG conductors, which are thicker than often found in Cat6 cable. By keeping the conductor's gauge size larger, there's less heat generation and less voltage drop over long distances, which results in better performance. PowerMax 500 Cat6 UTP cable also exceeds Class E channel specifications as set down in international standards and has been tested for 500 MHz up to 10 gigabit installations up to 70 metres. As some as you might be aware, Cat6 cable is rated at 250 MHz to 100 metres and will usually only support 500 MHz up to around 50 metres or so. That larger 23 AWG conductor is particularly important when it comes to PoE, which stands for Power over Ethernet. PoE allows devices like IP cameras and phones to be powered via the Ethernet cable rather than with a traditional power point and plug. This diagram shows the amount of power drawn by PoE devices. The original and still popular PoE standard was good for up to 15.4 watts. Then came PoE Plus, which generally meant 30 watts, but could support up to 60 by utilising both cable pairs. The latest PoE++ standard supports devices up to 100 watts. Sending that down cheap cable is asking for reliability issues and heat generation, which in some cases can even damage the cable. That heat issue is further compounded when multiple PoE devices are powered by a bundle of data cables. The heat generated in the cable bundle will raise the temperature of the cable, resulting in a weakening of the data signal and increased chance of data corruption. And as I just mentioned, can in extreme cases even damage the cable itself. Hence the importance of using quality data cable like DINTEK's PowerMax 500 series, which has a larger wire gauge to minimise these problems. A lot of cable on the market has a smaller 24 AWG conductor. Incidentally, AWG stands for American Wire Gauge, which is the international standard for measuring wire thickness. If we convert it to millimetres, 24 AWG is 0.5 millimetres in diameter, 23 AWG is 0.56. DINTEK also has a range of jacks, plugs and wall fittings to complement the cable. Also, different types of patch panels, even half use size, which can be handy in some situations. DINTEK also has shielded patch panels for Cat6A and Cat7. Cables and patch cords come in different lengths with either a PVC or an LSZH cable jacket. LSZH stands for low smoke, zero halogen, which means it emits limited smoke and no halogen, that is, toxic fumes when exposed to high sources of heat or fire. DINTEK also has a great range of tools and toolkits. Let's take a look at a few. One outstanding tool is the TechBench Termination Kit. This unit won the Cable Innovators Award run by Cabling and Maintenance magazine in conjunction with Pixie Vegas Conference. It allows installers to work in confined spaces in front or at the back of telecommunications racks and ensures that terminations are carried out with minimum fuss. If you've ever spent an hour or more bent over a rack or put a punch-down tool through your hands, you're going to love these. Here's a short video of it in action. As you've just seen, the Tech Bench greatly improves comfort when working on a rack. A very neat and compact tool that we know will make life a little bit easier for installers. Another great tool is the DINTEK E-tool for Cat6 Easy Jacks. These have an all-in-one punch down and trim action which will save heaps of time for installers terminating patch panels and wall plates. There's also a version available for vertical Keystone jacks. Here's a short video showing how they work. DINTEK E-tool Cat6 Keystone fit off. Okay, we've got our tool and our Keystone jack. First trim back the cable sheath, separate the pairs and trim out that bit of excess insulation material we don't need anymore. Insert the Keystone jack into the temporary holder, makes it a lot easier to work on. Lay the wires over the slots where they're going to go and give them a light nudge, make sure they're firm. Colour code's marked on the Keystone jack so you get them all into the right slots. Take it out of the temporary holder and stick it into the crimping tool and crimp and trim the excess wires all in one go. Stick the dust cover on and job done. Another innovative plug is the RJ45 pass-through easy plug. The design allows the wires to pass through the connector rather than butting them up inside. That also means the twists in each pair can be pulled closer to the contacts compared to conventional plugs. Maintaining the twists as close to the point of termination as possible significantly decreases crosstalk and increases performance. Here's a short video showing how these work. DINTEK RJ45 pass-through easy plug demo. Start by sticking the boot onto the cable and push it down out of the way for now. Strip back about 60mm of sheath and cut out that central divider. Sort the wires into the right order and trim off the wiggly bits at the end to make it easier to get through the plug. Push them through and pull snugly into place. Make sure the sheath is firmly inside the plug. Push the boot back up. Stick it all into the crimping tool. And crimp and trim all in the one action. Job done. Also notice that red pin inside the plug in the center picture there. That's an optional locking pin which prevents the plug from being accidentally pulled out of a patch panel or switch, something you definitely don't want happening if it's connected to something important like the main internet connection for a business or an important server. On to Optic Fibre. DINTEK has a complete range of fibre optic products including fibre optic cables, connectors, enclosures, adapters and couplers. DINTEK also has a range of fibre patch cords and cassette patch panels for data centres. The Easy Fibre Connect system on the right there is a toolkit which comes in very handy in emergency situations. It can restore a broken fibre connection back to working condition without expensive tools within a few minutes using mechanical splices and DINTEK's quick assembly connectors. It includes, amongst other things, Easy Fibre Quick Assembly LC connectors, single mode and multi-mode SC Easy Fibre connectors, Easy Fibre mechanical splices, and the Easy Fibre cleaving tool. Here's a short video showing how easy and fast a fibre optical connection can be made using a DINTEK mechanical fibre connector and the Easy Fibre Connect system. DINTEK Easy Fibre mechanical fibre connector demo. You'll need a few tools including cutters, cable strippers, and the easy fibre cleaving tool. Start with plugging the fibre checker into the good end of the cable. This just sends light down the cable to make it easier to see what's going on while you're working on it. Cut off the dodgy connector. Blame the apprentice for that one. Before we strip the fibre back, remove the screw on back piece and rubber boot from the connector and push it onto the cable down out of the way for the moment. Strip off the outer coating about 10mm at a time until you've exposed about 40mm. That way it fits across the width of the cleaving tool. And cleave. The cleaving tool ensures the exposed fibre is cut to exactly the right length for the connector. Watch where the rubbish goes. Give it a good clean with an alcohol wipe. Stick it into the connector, making sure first that the locking tabs are pulled out. Nice and easy. Don't try to force it. You'll know you're home when the light comes out the end properly. Then push the locking tabs back in firmly. Push the rubber boot back in under the clamp. Screw on the back of the connector. Finally, attach the boot cover. Job done. Now to some UTP basics. UTP stands for unshielded twisted pair. So why do we use twisted pair cabling and how does it affect performance? Twisted pair cabling is a form of wiring in which two conductors are wound together for the purposes of cancelling out EMI from external sources. EMI stands for electromagnetic interference. UTP is now used for most modern Ethernet networks and telephone communications. Basically, a pair of wires forms a circuit that can transmit data, and the pairs are twisted to provide protection against crosstalk, which is noise generated by adjacent pairs. Twisting the wires decreases interference and has the effect of cancelling out induced noise with each twist. This is because each twist of the two wires puts them 180 degrees out of phase. This is known as differential mode. Differential mode also reduces electromagnetic radiation from the cable and attenuation. Let's have a closer look at how differential mode works. For data transmission, we want the input voltage to be equal to the output voltage as shown here. If we put 4 volts in, we want 4 volts out. If we start to introduce electromagnetic induction on the wires from adjacent sources, we could be continually adding voltage to that line as we move along. For example, now our 4 volts at one end could end up as 8 volts at the other, causing data rejection and retransmission, which slows down the network. But if we add twist to the wires, as you can see here, it results in a reversal of the induced voltage with each twist. So the resulting voltage at the far end is the same as the input voltage we started with. Now let's have a look at the colour coding in UTP. UTP cable is 4 pairs of wires and each pair is identified using different colours. Blue is the first pair and a white stripe identifies the leading colour for each pair. So from pair 1 to pair 4 we have blue, white, blue, orange and white, orange, green and white, green, and brown and white, brown. Here we see the traditional use for each pair in a 4-pair UTP cable. The blue pair was originally reserved for voice and the orange and green pairs for data. The reason for this was that in the early days, voice utilises the centre 2 pins of the BT or RJ11 style plug and data went over a different type of cable. But with the advent of structured cabling, we needed to combine the 2 services into one cable. We came up with this system. So to combine both voice and data into one cable, the RJ45 plug was born. And for the sake of backwards compatibility with phones, the voice pair uses pins 4 and 5, and data uses pins 1, 2, 3 and 6. The last pair, the white, brown and brown, was used for PoE. Note that using 2 pairs for data allows sufficient transmission speed for 10 base T and fast Ethernet, but for gigabit we use all 4 pairs. Now for standards, there's 2 wiring standards that can be used under the TIA 568 standard. That's T568A and T568B. The difference between the two is that pairs 2 and 3 are reversed. That is, the green pair and the orange pair are reversed, as you can see in this diagram. In Australia, we usually use T568A, but provided you stick to the same pattern at both ends, it'll still work fine. If you use 568A at one end and 568B at the other, you end up with a crossover cable. These used to be necessary in the old days when connecting a PC directly to another PC, or when connecting hubs or switches without uplink ports together, but these days it's hard to find a network adapter or switch that doesn't have auto switching ports, also known as auto MDI or MDIX, or universal cable recognition depending on the manufacturer. These detect the type of cable and perform the crossover automatically if one is needed. This diagram shows the UTP pinout positions on an RJ45 plug. You can see here the colours for each pin from 1 to 8 depending on which cable standards is being used. You see left and right, the orange and green pairs are swapped depending on whether you want a T568A plug or a T568B. Now let's have a look at structured cabling. The definition of structured cabling system is that it is a set of cabling and connectivity products that integrate the voice, data, video and various management systems of a building, such as the safety alarms, security access and energy systems. There are a number of advantages in using a structured cabling system. Firstly, it provides a standardised cabling infrastructure throughout a building or campus. It's a flexible cabling system without regard to its ultimate use, so it can be used for voice, data, video or whatever without having to make changes to the cabling. Usually it'll have a patch panel in the communications rack, which is properly patched with nice neat cables that don't look like a bird's nest. Well, hopefully at least that's how it starts. It allows easier adds, moves and changes, so if a user moves to a different floor in a building, the phone and data cabling can be repatched to the new location without needing to run new cabling. As an example of that, I needed to move our phone after my wife decided to rearrange some furniture. Luckily, I'd anticipated this when I wired the house, so I already had a socket in place. So it was simply a matter of going to the patch panel and pulling the phone line out of one socket and plugging it into another to get the phone line where it was needed. Structured cabling also allows upgrading to different network types, provided the cabling work is installed according to the standards. This diagram shows the generic cabling infrastructure as defined in the ANSI TIA 5680-D standard for structured cabling. The components from left to right are the campus distributor, that's the CD there, to the main building distributor, BD. From there to each floor distributor, FD, that's backbone cabling. Then from each floor distributor to the telecommunications outlets, the TOs, is horizontal cabling. More often than not, the cabling within horizontal cabling will be twisted pair, except for that one time I was asked to look at an office network to see what I could do to speed it up and found they were still using coax. Here we see the horizontal cabling layout with some DINTEK components being used in typical locations. In the building and floor distributor areas on the left, we have racks, cabinets, patch and management panels, onto the horizontal cabling across the bottom, leading to Keystone jacks, wall plates and patch leads to the work area components on the right. Here's a diagram for the backbone cabling layout and typical components. We're basically connecting one building to another here using Optic Fibre, with everything needed at both ends like patch panels, cabinets and enclosures. And of course you've got your transceivers and switches there as well, which DINTEK don't have, but we can supply from our Draytech and Planet range. A commercial installation, the structured cabling system, consists of 6 separate subsystems, which are 1, the entrance facilities, where the cable enters a building. In the case of phone lines, that's often where the carrier's responsibility ends, and usually where you'd find their chrome-type block with lots of little red and white jumper wires all over it. Equipment rooms contain the main building distributor, where we'd find our switches, routers and PABX systems and so on. Telecommunications room contain floor distributors, basically more switches and patch panels for each floor or area. Backbone cabling connects the main distribution frame to the sub-distribution frames on each floor or area. Horizontal cabling is used to distribute out from the sub-distribution frames to the individual workstations, and work area components like wall plates and patch leads connecting the computers, phones, IP cameras and so on into the network. Any part of the structured cabling system will fit somewhere inside one of these subsystems. The diagram illustrates each of these subsystems in a multi-floor building. From the middle right-hand side, you can see the entrance facilities, then clockwise you get the equipment room, then onto the telecommunication rooms on each floor. Between each floor is the backbone cabling connecting the telecommunications rooms to the equipment room, followed by horizontal cabling on each floor, shown on the top left at number 5, then number 6 just below that is the work area components. This has been a short presentation of what a structured cabling system is, and we'll come back with more webinars in the near future to develop the subject. We also intend to provide some hands-on practice sessions in our training lab soon where you'll be awarded with an attendance certificate. If you're interested in attending one of these, please email sales@dintek.com.au and watch this space. For more information on DINTEK products, please visit our website at www.dintek.com.au or you can send us an email at sales@dintek.com.au.